Hi there, this is Hussain hutaylah, fire safety engineer graduated from the University of Central Lancashire in July 2021. I present my postgraduate research which was about study on fire behavior and smoke generation on combustible sandwich panels under fire. It has become evident that the rate of sandwich panels fires which have increased considerably, which have made these fires an increasing issue. The fire performance of sandwich panels is linked to the type of their cores, which are made of plastic-based composite materials. The core insulating materials most often involve highly combustible polyurethane PUR, expanded polystyrene EPS, and extruded polystyrene XPS, which have the tendency to stimulate fire development, generating an extensive rate of heat release rate and toxic fire effluent. The ignition and the fire from combustible sandwich panels cause the loss of integrity of the panel joints, which open an access to an oxygen supply, which will enhance combustion and so increase the fire severity, leading to an extensive fire development. A better understanding the building exterior wall systems fire behavior and smoke toxicity, including the thermoplastic sandwich panels, can decrease the impact of these fires on occupants in buildings. There is a need to increase the knowledge about the sandwich panels reaction when affected by fire, and this cannot be done without conducting fire performance and fire resistance tests. This study has the aim to determine the fire behavior and the smoke generation on combustible sandwich panels using colorimeter. As you can see, each sample is to be exposed to different heat flux, 25, 35 and 50 kilowatt per meter square. Result and analysis for PUR. To know the level of change in mass for each experiment, we subtract the final mass from the initial mass, and after that we divide the change in mass by the initial mass. This basically suggests that the more PUR is heated, the more percentage of a change in mass is higher. Unfortunately, the data about the total heat release rate were absent in all experiments due to technical issues. Then, for EPS overall results, the percentage of a change in mass for EPS has not increased significantly between experiments 4 and 5, but this decrease was more evident when EPS was under 25 kilowatt per meter square. This is due to factors such as the complexity of the pyrolysis process. For the CO yields, their rates increased with the increasing of heat flux, but for CO there's a fluctuation. And finally, XPS overall results. With regard to the rate of a change in mass as per the initial and the final mass, the percentage of a change in mass for XPS seems to be constant for all samples under the different heat flux infigured. Summary of the findings. PUR can be considered as the latest dangerous in terms of its flammability, while the extruded polystyrene XPS used as a core for sandwich panels is the most dangerous. Both EPS and XPS under the various heat fluxes generated high levels of heat release rate, peak of heat release rate, and smoke production with significant CO and CO2 yields. XPS produced an extensive peak of heat release rate reaching 678.6 kilowatt per meter square, with an extensive rate of smoke production and the high rates of smoke effluents, which can cause health and safety hazards. It's not advisable at all to use XPS and at a lesser extent EPS as a sandwich course. Evidence suggests that the PUR is the safest of all with less fire severity and acceptable toxicity.